The next job we've got here is to make a couple of flanged output shafts to suit a Ford Fiesta based chain drive unit. What I start with is a standard aftermarket Ford tripod type CV joint, an inboard one, and then I take a narrow cutting disc on the angle grinder and chop off the tripod end. That leaves me with a solid end to the flange. I'll then machine this down a bit to suit the flange that's going to come out of this billet of EN8 steel. This will get turned down to be a fit on here. Will be clamped up in a jig and then TIG welded on, and then after it's TIG welded it's trued up again with some more machining. The tapped holes get put in it and some clearance gets put in for the CV joint housing to move, and that's it in a nutshell. Takes considerably longer to make though. And the EN8 is reasonably tough to machine. It's not overly difficult, but with a small lathe it can tax it. The flange itself, part of it is heat treated and quite hard. This area here is fairly soft, but the further you get to this distance here, it can get very hard, particularly in this portion here where I'm trying to machine it down. Sometimes I have to use an angle grinder to get through the hardening on that edge. That's not a critically hardened part. The journals here and the body of the shaft itself are the more critical parts of the hardening. But so this journal here is a non-critical dimension. Do machine it down a bit so I can get it down to a size that the weld isn't interfering with the hole that I need to make in here. Oops. So there's I think it's about 78mm diameter hole through this side, and on this side that mates up with this, I think we get down to about 47, something like that. I'll need to measure it again. Yeah, I think it's usually about 47, 48mm. I machine this down to 20mm, yeah, 20mm long, and then it will sit some 6mm into the face of the flange itself, and then welds up, and then ultimately this gets a lot of the weight machined off it and out of it. But I'll show you that when I machine it. Now I've got all these nice bits of tripod left over. I suppose I could weld them to something. Make something decorative. Well, start off by turning down the stub axle. Drop it around the floor. Twist to make sure it's sitting centrally in the 3-jaw chuck. Machine it down with this type of insert, so it cuts it on the edge of this one rather than the point of the insert. And there's the other turning tool. Uses the same sort of inserts. That one cuts on the pointier end, and that cuts effectively the side end that you don't normally use with that one. so that way you get full use of the insert. It's quite good for doing the cuts in this hardened metal. Angle it a bit. It does get fairly hot, that stuff. It turns a bit blue. What I will do is I'll put a centre bore in there, which saves me taking the tip off my tool. There, where is it? Centre drills. Pressure on the end of the insert can get quite high as it approaches a little nub in the centre, so if I put a hole in there, it eliminates that. Need to take it easy with these centre drills, certainly into the hardened steels, toughened steels. It's quite easy to shear them off. I'll machine it down till the remains of this blackened surface disappears, and that I know that's the right depth I'm looking for, or really near the right depth I'm looking for. Just hitting that hardened portion at the end there. Right, that should be down to about 48mm. It's usually the diameter of that journal. Well, it's not a journal, it's a step anyway. Right, 54. Did I say 48? 54. Right, so it's sitting at 54.32. Yeah, 54.3. That's fine. The last 3mm is hardened on this face here, so that's going to cause me problems machining down, because the step goes down to 48mm, comes along and then comes up at a 30-degree angle to form a very small peak at the end. That gives me the welding preparation. But to get down to that 48mm, I'm going to have to grind 3mm off the back of this, because no way is my tooling going to cope with that, because it's really hard. Right, this is the bit I'm talking about here. That last, oops, that's hot. That last 3mm from there to there is very hard. You might be able to see a slight difference in the coloration. It was noticeable when I was machining that face there that it started to come off with bright orange sparks, and at that point, so in that face there needs to go down from 54mm to about 48mm, and that extends along to about here, and then steps up to meet this face in a point about half a millimetre wide at a 30-degree angle, and that gives me the weld prep angle that I need to get in to weld this piece to the flange. So what I need to do is take an angle grinder and take that face down to about there, so that the inside edge of that is down about 48mm diameter anyway. Well, that's messy and noisy, so I probably won't show you that. Okay, I've now chamfered off that edge down so that the hardened portion is below the 48mm. I need to turn along this edge, I started to turn some of this back, but what I'll need to do is set up my cross slide for the 30-degree angle that I want to cut. I'm just setting up the top slide at 30 degrees, there's a little graduated scale on the mark there, and a couple of nuts and bolts to tighten this up. I'm using the tool that's the opposite hand, so I'm cutting away from the chuck. Right, let's see if this will cut this. Right, I've now machined it down to 48 on this portion here, steps up at 30 degrees, and then I've got about a half-mil lip on the end. This half-mil lip is going to sit on a corresponding half-mil lip on the flange, and should give me enough penetration right through there to stop any crack at the weld. Got to take a little chamfer off that edge, it's a bit sharp. Right, that's the first stub machine down, ready for welding to the flange. Still quite warm. So the diameter at the very edge is probably about 0.5 millimetre flat around the edge there, is 54.3. There will be a corresponding bore in there at 54.3 that will sit into, but again it will only be about 0.5 millimetre of a lip, and then again there will be a 30-degree angle on this bore on here, which gives me the preparation for the weld that I'm going to put in. And this will be recessed in the depth of the step, which is about 6 millimetres. So I need to make that one look like that one. That's the second one. Then I need to do the flanges. I've got the 100mm steel billet in the 3-jaw chuck. I've bumped it around so that the outer diameter is running concentrically. The faces are not cut square because they were cut in a bandsaw, so if I turn it on you should see the face wobbling. You see the face is going in and out, but let's turn that off. But this diameter is set up to run true within a thousandth. Just put a clock gauge on that. Just my little clock gauge set up in a holder. It sits on the tool post. So what I need to do is, first of all, I'll put a bore through it. I will bore it out to 53mm diameter and then counter bore it to 54. That will give me that little 0.5 mil step on either side, and I'll put a 30-degree chamfer into the bore as well. And that will give me the weld prep for TIG welding the stub into the flange. Once I've got that done, I'll face back this face about 10mm, and then turn it around the other way and put another bore in and face the other face off. Right, I'll see what this one does. Right, getting close to the size now. Right, I've machined the outer face, so that's down to 12mm. Opened up to 78mm. There's a 45-degree chamfer between the faces in there, and there'll be further machining to this once it's welded in. Gets trued up after it's welded, and then it gets 6 threaded tapped holes around the 86mm PCD, and then it gets 6 little pockets put in to clear the inner of the CV joint when it goes at an angle. This is my holding jig for the welding of the stub axles. Just a simple threaded clamp. You can get a couple of tacks in and flip it over and do some of the welding, flip it back over and finish the welding off. So that just fits into my welding rotator. So what I'll need to do, I'll do a bit of preheating on this, get the temperature up. It helps to stop any cracking in the tacks if it's heated up a bit. That's the inside welded up. Let that cool off a bit, flip it over, and then do probably about 3 passes of weld on the other side. That's the first pass done. Again, I'll let it cool down a bit, see we're getting too hot, and then go in with a second and third pass. That's the third and final pass on that side. A nice fillet there. It was welded at about 160 amps. Well, the machine was set at 160 amps and using the foot pedal. So it's now slightly warm. So I'll take it out the rotator and let it cool down. Once it's cooled down, I can do the final machining. Running fairly true after welding. What we'll do is I'll just take a very light skim off the face to make it absolutely true, and then give it a quick clean up. Right, I've set this up in the rotary table to put 6 holes in on a 43mm PCD. I'm just putting pilot holes in to start with, and then I'll drill them out, 7mm to tap them out, M8. Right, and we'll change to ball-ended 8mm milling cutter to put the pockets in. Right, what I'll do now is I'll proceed all the way around and put the start and finish points and all these cutouts on each of the 6 segments. I find that I do this way it's a lot easier to machine without going wrong. It's not liable to go wrong, but that's the 6 cutouts put in there. Just a little bit of deburring to do on them. Right, that's the tapping drill. Let's roll the holes. Just change this to 8mm tap now. I'm just going to tap this by hand. That's the pair of stub axles finished off. It's welded around here and welded on the inside as well. It's designed for a 100mm outside diameter Lobro joint with the 86mm PCD. There's 6 M8 fixing holes. And this one's got the spline for the Ford Fiesta IB5 size differentials, which I just happen to have one here. And then in like that. And there we have a differential. Right. Roll off the bench, which is about to do. Stop rolling. Then to make this into a chain rise differential, we put an aluminium can over the body. Aluminium can, fabricated can, as you can see, made from a 10 gauge aluminium tube with an end plate welded on. And that slides on. And the other thing we have to do is plug up some holes in the face that would let the lubricant run out, so they get brazed up and reassembled. And the sprocket mounts in place of the crown wheel that would normally go on that flange. And then seal bearings on these journals here in an alloy bearing carrier, and then an oil seal runs on that journal there. These lock into place using a snap ring that goes in that groove. That slides in and locks behind the output gears in the differential itself. And there we have it.